Hello, welcome to today's class. Today we will be learning how to graph and describe quantitative data. In doing so, we'll examine the center, spread, and then also the shape. And we'll also learn how to identify outliers, and then also how to use StatCrunch to be able to compute this statistics. And so to describe a quantitative variable, we focus on three things. We will look at the shape, the center, and then the spread. And so to be able to talk about the shape, we are going to focus on how many mode or how many bumps the graph has. We are also going to determine whether it is skewed or it is symmetric. We would also be able to tell if there are outliers present or not. And so to be able to tell how many modes a graph has, first let's try to understand what a mode is. So mode is usually the data point that appears the most. So for example, when we look at this first data set here, and we are asked to compute the mode, like I did say, it is the data set that appears the most. And so when we look at this, we could see that the mode is 3. The mode is 3 because you can see from here, 3 is here, 3 is here, 3 is here. That is the only data point that appeared the most. Let's look at this example, the second one. We want to compute the mode of this data set too. And so we can see here 2 appeared twice, 4 also appeared twice, 6 appeared, 4 also appeared twice, 6 also appeared twice, whilst the 10 and the 7 appeared once. And so here, so here the mode, we can see here that the mode is 2, 4, 6. And so in these situations, there are situations where we could have more than one mode, and that can be evident in the second example. So here we have only one mode. So this situation is called a unimodal mode. And then here we have three modes. So this is multimodal. How are we going to, so this is how to be able to determine the mode when you have data sets. How are we going to tell or speak about the mode, whether it is unimodal or bimodal? Bimodal means that two modes, or multimodal, which means that three or more modes or more bumps. So to be able to do that, whenever we have a graph, we could be able to see from the bump. For example, when we have a graph and then we see it looks like this. So here you can see the bump is here or the peak is here. And so that is the mode. And so this is a unimodal mode. And then in situations where the mode is 2, it is bimodal. So you could have a graph too that looks like this. You see the bumps are 2. So in that situation, that is bimodal. And then where we have 3 or more peak or bumps, then that is a multi-modal graph. And there could also be situations where the graph doesn't appear to have any mode. And so, for example, if you have, let's look at this histogram here. If you have histograms that look like this, let's see. So you see, it doesn't have a bump, you see, or it doesn't have a peak. And so in situations where you have histograms where they approximately have like the same height, in such situation, it's a what? It's uniform. So because if you try to draw a curve, you're going to have something like this. So you see, there is no bump or peak. So when we have a graph, we use the peak or the bump to tell that is the mode. So you should be able to tell if whether as a graph or has a unimodal, bimodal, or multimodal, or it's uniform. Good. Now let's proceed. Now we want to talk about the skewness, or what we want to tell whether the graph is symmetric or skewed. A symmetric graph, to be able to see that a symmetric graph is usually bell-shaped, so it always looks like this. I don't know why this is messing up. So a symmetric graph, it looks like this. You see, it's like this. So it looks bell-shaped. An example is the normal distribution. So it is symmetric, and so it looks like this. And then sometimes too, it's not all quantitative data sets that are symmetric. Some of them could be skewed. And when we talk about skewness, we either have right skewed or left skewed. And you are able to tell whether a distribution is right skewed looking at the tail, and whether it's left skewed also looking at the tail. So for example, we know that this is symmetric. If you have situations like this, you see this, the tail is pointing towards what? The right. And so, I mean, these are like my axes. You can see the tail is pointing towards the right. And so this is what? Right skewed. So this right skewed, an example of that is like income data sets. So what this means is that majority of the people are here. And then say the Elon Musk and then the Jeff Bezos, they are somewhere here. The Elon Musk and the Jeff Bezos are somewhere here. So you see, they are far away from the rest of the people. And then we also have left skewed. So left skewed also looks like this. You see, where is the tail pointing towards? The tail is pointing towards the left. And so this is an example of what? This is an example of what? Left skewed. So when we have this histogram, you see, we can see from here, you see, it's looking like pear-shaped. See? So this histogram here is symmetric. This is also the right skewed. If you try to draw the graph, you are going to see it's see. Try to draw the curve around it. See? This is right skewed, and this is also left skewed. So you should be able to describe the skewness by you looking at the what? The histograms. So this histogram here is left skewed, this is right skewed, and also this is symmetric. And the other thing we also want to discuss is outliers. What is an outlier? An outlier is a data point that is significantly different from the rest of the data points in the data set. So for example, let's look at this class. Let's say that we have Yao Ming in this class. So you know Yao Ming is very tall. And so in such situation, he is an outlier because his height is significantly different from all of us in this class. Another example too is, let's try to look at income the income the annual income of people in this area. Let's assume that Elon Musk lives in this area. So you could see his annual income, because he's a billionaire, his annual income is way, way, way higher than the rest of the people in this area. So such situations, those are outliers. And then whenever there is an outlier in the data set, you could be able to see um, in the graph, you see, for example, you see this one's here. You see, and you should be able to comment or talk about them when you have those stuffs in your data set. Now we want to also describe the center. And so to describe the center of a data set, we are going to focus on two things. We are going to focus on the median and then the mean. These two describes the center, but they are different. They can be different. And also, there are situations where they are the same. There are situations where they could be different because the median is robust to outliers. What it means is that when there are outliers in the data set, the median is a bit resistant to outliers than the mean. So what do I mean by that? So for example, let's look at the annual income of people in this class. Let's assume that Elon Musk is in this class. So let's say our annual income here is say 40K, 55K, and say Elon Musk say 2 billion, right? And then we want to find the average income. Because of this guy here, the average income is going to go high, and it's going to give an impression that, oh, people in this class are doing well. But the median is going to be what, 55K, which is giving a true reflection of the situation. So in situations where we have skewness in the data, we try to rely on the median as the measure of the what, of the center, because that is more resistant to outliers than the mean. And then so now we in this class will be using software to compute these things, but I believe that it's also important that you know how to do them by hand or understand what is going on behind the scenes. And so whenever we want to compute the median of a data set, the first thing we want to do is to order the data set. So you try to order first, and then we count. If the number of data points is odd, and so then we can find the median by using this formula so that's the middle, that the n plus 1 over 2 position. And then if n is even, then the median is between two values, right? And so we try to identify those two values by using this formula, and then we try to find the average of them. Let's look at an example. So let's say we have this data set here, the first one here. We want to compute the median. The first thing we have to do is to be able to order this data set. How do we order them? Let's try to order them. So we have 3, 7, 12, 15, 18. So we have been able to order the data set nicely. And then how many data sets do we have here? 1, 2, 3, 4, 5. So this is what, odd. And so to be able to find the median, we want to do the n plus 1 over 2 position. And then this is 5. And so 1, 2, 3, 4, 5. And so the median is going to be 5 plus 1 divided by 2, which is equal to the third position. And so then the median is what? 12. 12 kg. Right. Let's look at this data set. We want to compute the median. So the first thing we want to do is to also order them. But luckily for us, this data set is already ordered because we have 5, 8, 12, 15, 18, 20. So let's count them. How many are they? 1, 2, 3, 4, 5, 6. So this is what, 6. This is even. And so we can be able to find the median by finding the average of the n over 2 and then n over 2 plus 1. So finding the average of the positions of these two. So the number here is 6. So 1, 2, 3, 4, 5, 6. And so we're going to have 6 over 2, which is going to be what? So we are going to have the third and fourth position. So we are going to have the median is going to be the third position is this guy, and then this is the fourth position. So the median is going to be 12 plus 15 over 2, which should give you 27 over 2 kg. That is the median. And then we already know how to compute the mean. Mean is the average of the numbers. And so to be able to compute the mean for this, and the formula is given by this. What this means is that the summation here means that we are adding everything here. So don't let the mathematical formula confuse you. What this mathematical formula stands here is that these xi's are the individual data points here. So it means that how many are there? There are 1, 2, 3, 4, 5. So we are summing from 1 to 5 of these observations or these data points. So don't let the formula confuse you. And then this n here stands for the number of them. How many are there? 1, 2, 3, 4, 5. So that is what it means. So it means that the x bar here is going to be 18 plus 12 plus 7 plus 15 plus 3 all divided by 5. And then you can use your calculator to compute this. I have already told you the median is less influenced by outliers. So in situations where we have skewness or in situations where we are faced with skew distribution, it's better for us to use the median to describe the center of the distribution. And it's very important that you understand this point here too. When we have symmetric distributions, the median, so sometimes when you even don't have the data set, when you don't even have the graph, and you want to, before you plot the histograms, you want to have an idea of what is happening. When the median and the mean are similar, it should give you an impression that the data or the graph is going to look symmetric, right? And also when the mean is less than the median, it should give you an idea that the distribution is left skewed. And when the mean is higher than the median, it should give you an idea that it is right skewed. Now we want to also learn how to want to describe the spread. So the spread measures how much the data values vary around the center. So let's look at these two situations here to explain why we need a spread. So for example, let's look at situation 1 here. So let's say this is the classroom. And then let's look at this place. Let's say here is the playground on Saturday morning. So in this classroom, let's say people are here. What is the average height in this classroom? So we can see the average height is going to look like this, right? And then you can see the variation to the center is very small because look at this guy. You see, his height to this guy is small. His height to the center is very small. So you can see that the variation is very small. Let's go to the playground on Saturday morning. So let's look at this is a parent. This is a toddler with the father. This is the sibling. And let's say this is another parent too. Let's say this is the average height here too. you can see that the average height for both situations are the same. But then here you can see the height from the first parent to the center is not that much. But now you can see from the toddlers, you see, their height to the variation is much as compared to the classroom, right? So you can see if you try to rely on say that, oh, the average height of the people that comes to the playground is this, you are not really giving a true reflection of what is happening because there are toddlers whose height are way, way, way different from the average height. So that is why we also try to also measure the spread. And also in measuring the spread, we are going to rely on the range, the maximum, the minimum, the range, the interquartile range, the sample variance, and also the standard deviation. Let's try to, we would use the computer to do this, but like I told you, I think it's also good for you to know how it's done. So I have a simple example that we would try to compute these things. And then when we are done, we are going to use StatCrunch to also compute this. So we have this data set here. We want to compute the range, median, and what have you. So we want to first start by computing the range. And so the range is the maximum minus the minimum, right? What is the maximum number here? 18. What is the minimum? 2. So the range is what? 16 pounds. The next thing we want to compute is the median. The median, we need to sort the data. Luckily for us, this data has already been sorted. So now we want to determine whether it is odd or even. Let's count 1, 2, 3, 4, 5, 6, 7. This is odd. And so to determine the median is the middle number, or we could also do and the n plus 1 placement position, which is going to give us 7 plus 1 divided by 2, which is going to give us the fourth position. And so we can see that the median here, what is the fourth position? This is the fourth position, 10 pounds. That is the median. The next thing we want to do is to compute the interquartile range. We've already provided those formulas here, right? So if you want to look at that. So to compute the interquartile range, we first need to compute the first quartile, which I denote by Q1. It is also called the 25th percentile. What it does is that we are trying to find the median of we divide the data into two parts and then we find the median of the lower the lower data set. So how do we divide this data set into two parts? So the first part, to compute the Q1, we try to do all data sets that are less than the median. And so we have 2, 4, 7, because our median is 10, and these numbers are less than the what? The median. Now, to find Q1, we're trying to find the median of this. What is the median of this? Is 4. And so we can see that Q1 is equal to 4 pounds. Let's try to find Q3. Q3 is also the 75th percentile. So that is the upper data set, all data sets that are greater than the median. So we have 12, 14, 18. And then we find the median of this. What is the median of this? So we have Q3 to be equal to 14 pounds. Okay. And then we know the interquartile range, which is what IQR is equal to Q3 minus Q1, which is 14 minus 4, which is also 10 pounds. Good. The next thing we want to compute is the sample variance. And then to do that, let's try to write the formula. You could go to the slides above, it's already there. And so the formula for the sample variance, which is x squared, is giving us so first and foremost, let's try to find x bar. X bar is a sample mean. So we know this is the same thing as xi over n. And so to find the sample mean, it means that we need to add all these and divide by the number of things we've added. So this is going to give us 2 plus 4 plus 7 plus 10 plus 12 plus 14 plus 18, all divided by 7. And when we do that, we have x bar to be 9.571 pounds. Now, to compute the sample variance, let's try to create a table to do that, right? So let's have my xi's here, okay? I have 2, 4, 7, 10, 12, 14, 18. Okay, so we have this. Now the next we have x bar already. Let's create a column for xi minus x bar. So what this means is that take each of these data points here and subtract from the mean. So we have 2 minus 9.571. This should give us, that should give us negative 7.571. And so you can be able to use that idea to compute for the rest of the next one is also going to be 4 minus 9.571, which should give us minus 5.571 and then minus 2 point. So then the rest should be 2.571, 0.429, 2.429, 4.429, 8.429. Then we want to compute the last column. We want to do xi minus x bar all squared. What it means is that we've been able to do this. So whatever is here, we square them. Now, it's very important that when you are doing this, you put them in parentheses. Otherwise, you are going to get negative numbers. So from here, it's going to be negative 7.571 all squared, right? Negative 5.571 all squared. And so when you do that for all of them, here should give you 57.320, 31.036. And then here should be 6.610 and then 0.1840, 5.900, 19.616, and then 71.048. Now we've done most of the work already. So now to compute the sample variance, which is x squared, all we need to do is to sum all the numbers in this column. Sum all the numbers in this column. So we add 57.30 plus 31.036 and all that. So you have your calculators, you can do that. So when I did mine, I got 191.714 divided by, remember the formula says n minus 1. The n here is 7. And so here is going to be 7 minus 1, which should be 6. So 191.714 divided by 6. And then I got 31.952 pounds squared. If you want to compute the standard deviation, always remember is the square root of the variance. So anytime we compute the variance, we don't need to go worry ourselves with any other calculations. So we just need to find the square root of the variance. And so then the standard deviation is equal to square root of 31.952, which gives us 5.6526. I don't know why my stuff is writing that way, but it is 5.6526. That is how to compute that. And then now we want to use StatCrunch to compute these numbers. So please open your StatCrunch and then let's do that together. So this is the StatCrunch. Now let's try to input these numbers. So we have 2, 4, 7, 10, 12, 14, and then 18. Let's name this thing here. It was weight. Okay. Now we want to do all the computations with it. So you come here, you come to stats, and then you go to summary stats, and then we go to columns because we want to do the summary stats for the weight, and that is in the column. So we click on this one, and then you come here, and then you click on weight. What do we want? This n here is the number of data points. So I'm using the max. So I place my hand on command, and then I want the mean, variance, standard deviation. I want the median. You could also compute the range. You could do Q1, Q3. You could do IQR, interquartile range, and you could also do mode. So now we hit compute, and you can see that it has been able to do that for us nicely. You can see from here. So you can see this is the mean, which is similar to what we had. This is the variance, this is the standard deviation, this is the median, the range, and then the interquartile range. So this is how to do that in StatCrunch. Thank you for your time. I'll do another video to show how to be able to describe the quantitative data, do those graphs, the stem and leaf graphs, histograms, and all that. Thank you for your time.